Hey, so here's a review of what we learned in Lesson 45, which is the introduction to the unit circle. Now, the unit circle is a circle with a radius of 1 centered at the origin. What that means is that this is my x and my y axes. The circle is a radius of 1, so that means from the center point to any point on the outside edge, all of these distances are all equal to 1, 1, 1, and 1. Okay, so that means that to go from one side of the circle to the other, it's 2 across, but we really usually only care about the radius. So this is 1 and 1. So that's how big the circle is. It's pretty small. Now, what we do with this circle is it defines all of what sine and cosine are. The functions are defined from this circle. When we are looking at this, we're thinking about angles. And the way we think about angles is we start with the positive x-axis being representative of 0 degrees. Now, if I go up from here to here, right, like how many degrees is in this angle? Well, a right angle is 90 degrees. And this right here is a right angle. And it would have a little square in it. It's 90 degrees there. So the direction we travel is counterclockwise. So it's 0, 90. That makes this over here 180 degrees. Down at the bottom is 270 degrees. And as we come full circle, 360 degrees is the same thing as 0. Now the way that we graph one of these angles, if I'm imagining an angle in the first quadrant, this is the first. If I'm imagining an angle over here, then that angle looks something like this. I create a line, and that line is what we call the terminal ray. Okay, so whenever you pick an angle, you say, hey, Mr. Costello, graph this angle, whatever amount of degrees this is. We could say that this is 45 degrees, or maybe it's 50, or it doesn't really matter. When you tell me that degree measure, I draw a line, the terminal ray. Now, what that's saying is that the distance between here and here, this angle measure in here, if you remember a little bit from Geometry Algebra 1, you know that we write the angle measure, the number goes in here. So this looks like somewhere in between a 0 degree and a 90 degree angle. Well, I can't estimate based on what it looks like. So what I do is, just like any other number that we don't really know, we represent it with a variable. You might want to put x here, but x isn't what we're going to use. What we're going to use is we're going to use theta. Now, theta is a variable that represents an angle measure. So anytime you see theta, we know that that's an unknown angle. So let's recap so far. You have an x and a y axes. You draw the unit circle on them. The unit circle has a radius of 1. The center is at the origin. That's the point 0, 0. Okay? Now, if you're given an angle, you draw a terminal ray that represents that angle. The angle goes inside, and we call that theta, because I don't know what it is. It's representative of any angle. Once I draw this line, it creates an intersection point. And that intersection point we would call x, y. From that point, we drop a perpendicular line to the x-axis. Perpendicular meaning it creates a right angle there in the corner. Now this is where the tri in trigonometry comes from. The T-R-I in the beginning of the word is the same as in the beginning of triangle. So this is the triangle that we speak of. If I was to graph this point, x comma y, this point here, right? The way that we graph a point is we start at 0, 0, and we move over how many units? Well, as many as the x value. So if it was a 5, I would count over 1, 2, 3, 4, 5 units. But it's not 5. We don't know what it is. So we're going to represent it with x. So to go from here, the center, the point 0, 0, to the point x, y, that means that this distance on the bottom is x, and this distance on the side is y. Now, because of the definition of the unit circle, we know that this length from here to here is a radius to the circle. And since it's a radius to the circle, that means that the hypotenuse of this triangle is 1. All hypotenuses in the unit circle are radii. And that means that they're equal to 0, 1. Now let's do a little throwback to SOHCAHTOA, because trigonometry has to do with sine and cosine. So if we do a little throwback to SOHCAHTOA, you may remember that it's SOH, CAH, TOA. That means that sine of an angle, which we'll call theta, is equal to the opposite side length over the hypotenuse. So sine of an angle, sine of this angle here, is equal to the opposite side, which is equal to y, over the hypotenuse, which is the diagonal side, the longest side, this guy, it's 1. So essentially, if we simplify this, we get that sine of theta is equal to y. So this right here, this y, the height of the triangle is sine theta. If I use cosine, I know that cosine of an angle, theta, is equal to the adjacent side over the hypotenuse. Now, adjacent means next to. So you tell me, if I'm talking about this angle here, what side is next to it? That is, this is the adjacent side, the x. And what's the hypotenuse? Still 1. So that means that cosine of theta is equal to x over 1, which is x. So cosine of theta is equal to x. Now this is all fine and dandy, but normally we don't have quite so much writing when we're dealing with this in the regular sense, so let me give you an easier, cleaner copy. Let's do a clean copy here. Got an angle, I'll call it theta. Drop a perpendicular line to the x-axis. That forms a right angle. What's the length of this side here? 1. What about here? The base of the triangle is cosine of theta. And the height of the triangle is sine of theta. Now, it's important to understand what cosine and sine are because it can get a little easy to be lost in the terminology. cosine of theta is a function this pen is way too thick. I'm smudging all my letters together. Cosine theta is a function that takes in an angle measure. So what do you put into a cosine function? You do a cosine of some angle. So you process the angle with the cosine function. And what does it output? It outputs the base length of the triangle created by the terminal ray. Now I could write a lot more about that, but I'm hoping that you remember the construction, the process, so that I don't need to write any more than that. I'm sure you don't want to write any more than that either. So sine of theta, it also takes in an angle, right? Because that's what goes in, theta, and theta is an angle. So sine of theta is a function that takes in an angle measure and outputs the height of the triangle created by the terminal ray. So sine and cosine change depending on the angle that gets plugged into them. Now I can show you guys, if you have an Android device, you can find this app under this exact name, but I'm sure something like it exists for Apple as well. Let's focus on how things change for cosine first. Remember that cosine is the base of the triangle. It shows how wide it is, right? So this is about the triangle we were looking at before. You can see that the base of this triangle is 0.71. At 0 degrees, the triangle gets really flat and really wide, so at 0 degrees, the base of the triangle is equal to 1. So cosine of 0 degrees, if I plug 0 degrees in, it's going to give me back out 1. Now, as I go up, you'll see that cosine gets smaller as we get towards 90 degrees. And it actually becomes 0. The triangle has no width. So if I plugged 90 in to the cosine function, I would get out 0. Now, as I round into the second quadrant, somewhere between 90 degrees and 180, you'll see that it increases, but to -1. The triangle is getting wider, but it's flipped. It's going in the negative direction now. So cosine goes down to -1. My triangle gets taller again as we move into this quadrant, which means that it's also getting thinner. So cosine is getting smaller. And cosine of 270 is equal to 0. Round back to 360, and cosine is equal to 1 again. Sine is a function that takes in the angle and tells you how tall the triangle is. So let's see, how tall is the triangle right now? 0, because the triangle is flat. As I go up towards 90 degrees, the triangle gets taller and taller and taller, and at 90 degrees, the triangle becomes height 1. Now, what happens to the height as I go this way? It's getting shorter and shorter and shorter and shorter. until at 180 degrees, the height is 0. Round from 180 down to 270, and you can see that the height goes negative. It gets taller in the negative direction down to -1. So sine of 270 is -1. And as we round to 360 degrees, you'll see that it gets shorter again, and it gets shorter and shorter and shorter, and then the height becomes 0. So that's what the sine and the cosine function do as we plug different angles in. They all change and they vary, but they only vary between 1 and -1. And they hit 0 and then 1 and then 0 and -1, and cosine does the same exact thing. It varies between 1 and -1. It hits 0 twice, so 1, 0, -1, 0, back to 1 again. These are cyclical functions. I can keep going around above 360 degrees as well, and the same pattern happens. Now, I believe this is all that needed to be addressed from this, besides an explanation of what to do on the handout. Now, with the handout, which looks like this, some of you had sine and some of you had cosine. I'll do a couple points on the sine function just to give you an idea of what you're supposed to do, but I will not finish it so that you sine functioners don't cheat and just copy all my answers. So if I have sine of theta, what I want to do is I want to fill in this table. I have a value on the bottom, and I want to evaluate the function at different degree measures. So if 0 is theta, that means that I'm doing sine of 0. So let's see. 0, 30, 60. I'll do those three. So what I want to do is I want to do, first off, make sure my calculator is in degree mode. So I'm going to hit mode. I'm going to scroll down to degree and hit enter. And I can quit. Now I want to find out what sine of 0 is. If you just watched me mess around with that app where I can spin around the unit circle, you may actually know what the answer to this is already. Sine of 0, the height of the function, the height of the triangle at 0 is 0. Sine of 30 degrees, it's a little taller now, it's going to be 0.5. Sine of 60. Now that's an ugly decimal, so we're going to cut it off at 3 decimal places, 0.866. Okay. So 0, 0.5, 0.866. And you would keep going from there, fill in the rest of the table, and plot all those points. I would plot them exactly like this. My degrees is on my x-axis, 30, 60, 90, 120, etc. So at 0, I'm right here, 0, 0. At 30, I'm at 0.5, which is around here. And at 60, I'm at 0.866, which is somewhere around here. It doesn't have to be exact. And when I'm done with all of them and I have all my points on here, I will connect all these lines with a smooth curve. If you're confident enough to get it done in one line, feel free. You probably want a pencil for that part, but for me, I can just keep erasing and cheating. Yeah, like that. And it'll come up and back down, and you'll get an idea of what the function looks like. Okay, so I hope that helps clarify some points, and I'll see you in class tomorrow.